Hi, I am Balcandra Padwell, Business Development Manager for Optimized Solution. I will discuss with you pump and system optimization and life cycle cost. Plant study and analysis state, pumps constitute 33% of total electricity bill of plant. Operational cost of pump lies between 40 to 90% in 1 year life cycle depending upon pump size. Study conducted on 50 HP pumps for life cycle cost shows 84% of the cost is due to operation, while only 13% is your initial cost of purchase during first year. Operational cost is recurring, that is, it has to be paid every year. Do you know the 100 HP pump set can cost you 42.44 lakh rupees for 1 year operation? To bring to your attention, we have plotted time versus cost for 100 HP motor with 92% efficiency. So if you save 6 to 10%, you save nearly 3.5 to 4.5 lakh rupees per year. Think on it. Study of plants indicates various size of pump installed in the plant have a potential for saving energy. We have plotted pump size versus energy saving potential. We have briefly incorporated pump and system optimization process activity for your reference. We see numerous opportunities for energy saving in your plant. Have you ever considered of appointing pump specialist or pump consultant for such job? It looks unconventional, right? So within next 3 minutes I will briefly discuss our specialized work with you. In global scenarios where competition is tough, survival of fittest is not myth. Increasing production rate, increasing profitability and reducing operating cost has become necessity. One way to reduce operating cost is to optimizing pump and system and takes a life cycle cost approach. As a specialist in fluid handling system, we practice the best application engineering approach for your pump and system. Take a look at performance curve sensitivity for pump reliability. Power required equals flow into head into specific gravity divided by constant factor of design into efficiency of pump into efficiency of motor into efficiency of drive. Consideration should be given for overall efficiency of pump system. Any idea what is law of affinity in pumps? How to use it? How does it affect performance of centrifugal pump? For variable speed drive pump set, law of affinity plays an important role to calculate saving in power. By using law of affinity using speed, flow rate is directly proportional to speed. Head is directly proportional to square of speed. Power is directly proportional to cube of speed. This will give idea if speed decrease, power is reducing by cube root. Law of affinity is also applicable for diameter of impeller. An example illustrating law of affinity. Please see the power saved during speed reduction. There is significant saving of brake horsepower by running pump with VFD at lower speed. How often do you throttle valve in your plant? If you do frequently, you seriously need pump specialist in your plant. Take a look at Q versus H diagram. You can save a lot by working with us. How many bypass lines are installed in your plant? How often you use it? Are using it for 1 to 2 hours or more hours a day? Very big pump with short span. We recommend you to contact us. Do you have any idea how much operating cost saving is possible using variable speed drive at various load cycle? Take a look at. Now using adjustable speed drive, the power at shaft is reduced and drive efficiency is nearly 90%. Total power weight input is 20.63 kilowatts. So there is saving of 9.91 kilowatts. These can save 520,275.00 rupees per year. Let us consider an example for life cycle cost of pump. We have considered 4 conditions. Condition a new control valve installed. Condition B trim impeller. Condition C use a variable frequency drive. Condition D do nothing. Condition A and Condition B works out to be very expensive in long run, while trimming impeller work out to correct option for this process. Use B and B actually saves energy, but due to high initial cost of purchase and high maintenance cost it work out as second best option. If there is uneven throttling, then B&B works as best option then using trim impeller. There is limitation for trimming impeller. You cannot trim beyond 20% of the full impeller size. When should you use the FF1 motor? Is there any saving? How much it can be? Use the FF1 motor compared to standard motor for continuous operation. The payback period can be 2 years or less depending upon duty condition and size of motor. Do you have any idea which positive displacement pump is correct for your application? What type? How much it will cost? And why? We will select the correct type of pump depending on your application demand. See classification of positive displacement pumps for your reference. We will cover positive displacement pump in depth in our next video. What will happen if you use undersized pipeline or oversized pipeline? In both cases you will be spending more money due to wrong pipe size selection. Take a look at life cycle cost of pipeline. Energy cost or operation cost is nearly 88% due to wrong selection of pipe size. By using our approach to select pump you will enjoy numerous benefits. Have a look at it. We shall work with you for sourcing of material, sizing and selecting correct type pump and system, selecting type of material, selecting correct mechanical seal, selecting correct drive, calculation suction and discharge pressure, troubleshoot etc. Now do you have question in your mind? Why should you use pump specialist for your plant? What can he do? Can he save millions of rupees each year? We are certain we can save lot of money on plant operation. Do you have any idea how many things are involved in pump selection activity? How do you know which pump is correct and which pump is wrong? Which brand of pumps should you buy and why? It requires study, knowledge and experience with all types of pumps and recommend proper pump for required application. Decide yourself. Thank for time and attention.